Hello everyone, my name is Rashmi Vijay Sundara. I am from Senate campus following the University of Wolverhampton Mechatronics Engineering program. And in my research, I will be focusing on enhancing gripper force regulation for handling fragile objects based on current sense motor controllers. In this presentation, I will give a brief overview about the introduction to my research, the main research gaps, research questions that will be answered, methodology, and conclusion. Can you hold a tomato without crushing it? Most probably yes. Even a very small child finds such tasks very simple and easy to do. But when it comes to robots, robots find these tasks extremely complex and difficult to do. For example, if I give a robot a cup filled with and without water, the robot wouldn't exactly know how much force to be applied. And usually this is achieved by using very expensive sensors, expensive and complicated sensor systems, and very computationally intensive algorithms. And with the increase in automation, the use of robots in our day-to-day life is increasing. So we really need robots that are low cost with human-like touch. In my literature review, I found that most of the grippers used for handling fragile objects are made out of soft materials and they are called soft robotics. These soft grippers are usually made with material like silicon with different textures, and they might be actuated uh, using certain fluids or even magnetic actuators. And another prominent one is these pneumatic grippers, where they make use of these lateral springs for compensating for the force. But the problem with these pneumatic grippers is that they only work in fully open and closed positions. And another really famous one is these vacuum suction grippers, where they make use of the suction of the vacuum for grasping objects. But the problem with all of these is one, you need an additional gripper design for handling fragile objects depending on your application. And also, they are not very precise, so they cannot exactly control the grasp force that will be applied, and they might not be suitable for certain applications like medical robotics, space robotics, and underwater robotics, where the environment in which that the gripper has to function varies immensely. So in my research, what I'm trying to answer is there a way that we can implement current sensing on the pre-existing grippers so that they can handle fragile objects with minimal additional sensing. So I started out by the development of a three-finger rigid gripper, which is actuated with a single actuator. Then the mathematical model of the actuator is designed, and then the relationship between current and torque is developed. Then a current sensing circuit is used to measure the grasp and evaluating this gripper's performance in real-life applications. So the first stage was CAD modeling. So here it was essential that this gripper design was very simple, low cost, and light in weight. So most of the structure of this gripper was made from aluminium, and the design revolved around two 3D printed parts, which are the top plate and the base plate. And the nut and bolt mechanism is used to open and close this gripper. After that, the actuator, which in this case is the DC motor, the parameters of this DC motor are estimated approximately, and then the transfer function of this DC motor is derived. Then, with the use of this motor parameter estimation and the transfer function, a mathematical model of the DC motor is implemented in MATLAB Simulate. Then, to this DC motor model, different step inputs are given to represent different torque values, and how the speed is changed is observed. After we establish a relationship between force and torque, then we can measure this force as a current current value, which will be mapped on as a difference in voltage. So to measure this voltage, we need a current sensor. So we first experimented with ACS712 current sensor module. However, the resolution of this module was not sufficient. So then we made use of a shunt resistor that was trial and error tested to find the most optimum shunt resistor value to measure our specific current. So here you can see some results of how this current varies with time when the gripper is opening and closing and grasping and releasing at different stages. This table below summarizes all the threshold values and the gripper's respective state, and you can see that it ranges with a wide variety of, like, it ranges over a period of values, and we can clearly identify the different stages of the gripper's performance. And then next, the ADC resolution is not the main problems that we encountered was that the ADC resolution was not sufficient to precisely determine the grasp point. So, for example, when handling an object like an egg, the amount of force that has to be applied before this egg breaks is of a larger bandwidth. So we have room for error. But when it comes to another object, like maybe lifting a sponge, the amount of force, even a very small amount of force, can damage this sponge. So that needs to be considered. And another one is the object orientation needs to be considered. What I mean by this is that this gripper is tested in a predefined workspace, and the orientation of the object is predefined as well for optimal grasping. But in real life applications, the objects can be placed at different orientation. So when the object is placed at different orientation, the amount of grasping force needed to lift this object might also change so that it doesn't get crushed. So in the future, that needs to be improved as well. And another one is that the gripper's design can be optimized so that it generates less torque. Finally, it can be concluded that this research shows that instead of using any additional sensors, the motor itself can be used as the sensor to identify the grasp point with change in current. So it shows that low cost and no additional sensors are required, and that this can be implemented on pre-existing grippers. In the future, the accuracy of the ADC will be improved, and another addition is that we can implement a software optimization where we can implement a neural network or a machine learning algorithm so that our data which is collected while grasping objects, we can develop a model to predict at which point exactly in our data set the grasping happens. Rather than having to hard code this range, we can allow our algorithm to self-adapt. Overall, the uh, research shows grasping of objects based on the change in current. And thank you.